Okay, in this video I'm going to be going over Module 13.4, Modeling Interest Compounded Continuously. So before we talked about compounded n number of times, so that could be 4 times per year, 3 times per year, daily, which is 365. Instead, we're going to be talking about when it's continuous. So how does that kind of change our formula and what do we use? So what this is explaining up here, it's saying by letting m equal n over r, you can rewrite the model that we were using before as 1 over m. And this n is m times r, so if you were to solve for n, you would multiply by r to the other side. And so because r over n equals 1 over m, we have nt equals mrt. Then rewriting that, we could get this right here. And letting n increase without bound because it's continuous, right? It's just happening. You can say that causes m to increase without bound, and you'll see that this here approaches e. So what is e? E represents 2.7 ... and it keeps going. So the model simply can be rewritten as this here. So this is the formula we're going to use when we talk about continuously. So continuously, here's our formula. So using this formula, let's go ahead and identify some of these key things. So P is the principal amount. R is your rate. And remember, this is being compounded continuously, which is why we're using E there. So our principal amount, a person invests $5,000 in an account that earns 3.5% annual interest compounded continuously. So it's saying when will the value of the investment reach $1,200? So if I have V of t equals P-E-R-T, I'm going to take these values and plug them in. So when will the total equal 12,000? P is 5,000. E, and then our rate is 0.035, and we're trying to find T. So if I do what we did before, we can graph y equals 12,000, and so they did that here. And then they also graph this side, and you're finding where they intersect. So where they intersect here is x equals approximately 25. So the investment reaches 12,000 in approximately 25 years. So the most important thing here is why are we using this formula versus this formula here? And that's because this one is continuously. So when you're talking about compounded continuously, this is the formula you're going to use. Okay, for example B, let's read it first. It says the principal amount, $350, earns 6% annual interest compounded continuously. Find when the value reaches $1,800. So when it says continuously, I should automatically know that I'm going to be using PE to the RT. And so my P, my principal amount, we identify as $350 because that's the initial amount. My rate is 6% annual interest, so that's 0.06. And I'm going to go ahead and plug both of these in. So P is $350. And my interest is 0.06. And we want to know when this is going to all equal 1,800. So graph the function on a graphing calculator where y equals 1,800 and find the point where the graphs intersect. So if we look at this, we see where they intersect. Y equals 1,800 is here, and our function graphed here. And it identifies that they intersect when x is approximately 27.29. So the function value here is 1,800 at approximately 27.3. So the investment reaches 1,800 in approximately 27.3 years. Go ahead and try your turn. Make sure you identify which formula is the correct formula based on how many times it's compounded.